Watch the complete playlist on the app Pions. Download the app now.
Find the equivalent capacitance of the combination of capacitors between the points A and B as shown in the figure. Also calculate the total charge that flows in the circuit when a 100-volt battery is connected across point A and B. So I hope this is clear to all of you. This is our diagram, okay, circuit diagram of all the capacitors which are connected like this. Let's see which one are in series and which one are in parallel. Okay, so first of all, when just imagine that current or the charge is like water. So if you allow the water to flow like this, okay, this water is getting splitted over here, right? If this is one pipe and this is another pipe, okay, the water will get splitted over here. Since the water is getting splitted at this junction, we call it as junction. In the next chapter, we will call it as junction. So this point, okay, here this part and this part, okay, they are parallel, okay, they are parallel to each other. So here the same water is flowing like this, okay, no matter it looks like this, but the same water because it is not going anywhere. So here the same current is flowing here, okay, or charge is getting stored across the capacitor. So this 60, this 60 and this 60, they are in series. Let me repeat again, 60, 60 and 60, these three are in series. Let's find the equivalent in series. So 1 by C equivalent in series will be equals to 1 by C1 plus 1 by C2 plus 1 by C3. This is the formula for three capacitors in series. Now what is here? C1, C2, C3 all are 60. So let me write here 1 by 60 plus 1 by 60 plus 1 by 60. Sir, you didn't convert this into microfarad? No, I will convert this microfarad into farad at last when we will find the charge. Okay, to find the capacitance, anyways the final answer will be in microfarad, so no need of putting 10 to the power minus 6 and getting confused, right? So 1 plus 1 plus 1, this will be 3 by 60 over here, that is 1 by C equivalent. So this implies C equivalent of the first branch is 60 by 3, sorry, and that is 20 microfarad, right? So let's redraw this diagram. Let me draw here. This is over A, this is point A, and from point A our 40 microfarad is going over here. This is 40 microfarad, and from 40 microfarad 1 is going like this, okay, and let's call this as a C point, okay, and this point as D. So at point C there are two wires which are going. One is I am drawing like this, okay, and one is I am drawing like this, okay. So this is our point C. The upper branch had three capacitors which I have solved just now, and I can write, instead of these three, I can write a single capacitor of 20 microfarad. So this will be 20 microfarad over here, and the below one, the below wire which is going from C, that will be 10 and 10 in parallel. So let's make here again 10 and 10 in parallel, and they both are connected here, and this is connected across point D, and that point D is further going across point B. Clear? So this is 10 microfarad and this is also 10 microfarad, right? So our circuit gets simplified like this. Now now let's see this 10, 10 and 20. All three are in parallel, as you can see, because 20, the resultant is parallel in 10 and 10. So resultant of these three across CD, so C equivalent across CD will be equal to 20 microfarad plus 10 microfarad plus 10. We can directly add them. Why we can directly add them? Because they are in parallel. So 20 plus 10, 30, 30 plus 10, 40. So this is our 40 microfarad. Done. So let's redraw between A and B. We already have one with 40 microfarad. Another one we got just now with 40 microfarad between A and B. Let me repeat again. Our C and D, we got it as 40. Now 40 and 40, they are in series. So what will be our C equivalent in series? So across AB, the equivalent capacitance, this is across CD, okay. Let me write here across CD. So AB will be 1 by C equivalent, that will be equal to 1 by 40 plus 1 by 40. And 1 by 40 plus 1 by 40, 2 by 40. So let's go down here. So C equivalent will be equals to 40 upon 2. which is equals to 20 microfarad. I hope this is clear. So the whole circuit, this whole circuit can be written as a single capacitor with 20 microfarad. That is called equivalent. Let me remind you once again, equivalent means all those capacitors which are joined in this particular fashion can be, said equivalent to this. Sir, what is equivalent? Same. They both are same. So even this whole circuit is giving 20 microfarad capacitance and even this single capacitor. So either you join a single capacitor with 20 microfarad capacity, or you join so many different capacitors in this particular fashion. Clear? So this is A and B capacitance. Now let's read the question once again. Find the equivalent capacitance of the combination. We found it as 20 microfarad. Now also calculate the total charge flows through the circuit. When you are finding the charge, you have to get it in a standard unit. So we know that our charge across the circuit can be found as Q equal to CV. Correct? Now what is the equivalent capacitance here? 20 microfarad. Be very careful. You have to convert it into 10 to the power minus 6. That is farad. You have to get it. Because standard unit for charge is coulombs. That is only if 1 farad multiplied with 1 volt, that gives you 1 coulomb. That's why you have to convert this into farad into 100. So this will give us 2000 or 2 into 10 to the power minus 3 coulombs. That's your charge which is flowing in this whole circuit. Be very careful, since the question is saying what is the current, what is the charge flowing between AB. This is the charge. They have not said what is the charge across each capacitor. That will be different. So across each capacitor it will not be 2 into 10 to the power minus 3. This whole circuit it is 2 into 10 to the power minus 3. For individual it can be 2 into 10 to the power minus 3 like in this case, and for other cases like this branch and this branch, the charges will get splitted.